Okay, so for those of you joining us on YouTube, we are starting with these last 6. I know some classes finished them, some didn't. I just made everybody sit for 5 minutes and try these. So if that's you joining us now, pause the video, try these, and then jump in with us. But we're ready to go over them now. All right, so guys, sine is which variable, X or Y? Y, good, and Y at 90 is 1, perfect. All right, what about, let's do cosine of pi. What's cosine in terms of X and Y? X at pi is -1, very good. All right, tan of 3 pi over 2. Tan is what in terms of X and Y? Y over X. What's your Y at 3 pi over 2? And -1, good. And what's your X? Good. What's anything divided by 0? Nope, undefined, good. If the 0 is on top, then it is equal to 0. But if not, it's undefined, and that's a totally legit answer. That is okay, you will see that. Any questions on the first 3? All right, secant of negative pi over 2. Let's do secant first. What is that in terms of X and Y? 1 over X, good. And I'm doing negative pi over 2. Where's that? What's that the same thing as? What'd you say, Ethan? 270 or positive 3 pi over 2. These are all the same as that angle right there. So we're going to go do 1 over X at 270 or 1 over X at 3 pi over 2. What is my X at that angle? 0. What's 1 divided by 0? Undefined. That's okay. Just told you that was an okay answer. All right, next I've got cotangent of 780. All right, let's do cotangent first. What is that in terms of X and Y? X over Y, very good. Now, 780, is that on your unit circle? How do we get it? I think it's 2 full times around. So if I minus 360, that's, I guess, yeah, 360 is 1 time around, or like 2 different pies. So if I minus 360 off, anytime you see a number that's not on your unit circle, just start minusing off 360 until you get one that is on your unit circle. So that becomes 420. And then I minus 1 more 360, and that gives me normal 60. So 780 is the same thing as 60. They're the same angle. They mean the same thing. So we want to do cotangent or X over Y at 60. So what's my X at 60? Good. And what's my Y at 60? Very good. So 1/2 divided by √3 over 2. Again, I've been arguing that you will start kind of getting the hang of these or seeing a pattern with these. Even if I don't remember exactly what it is, I know that once I multiply by the reciprocal to get rid of that fraction, I get 1 over √3. And by rationalizing it, I get √3 over 3. That is my answer. Ellie? Great question. So I think about my little unit circle, and instead of going up and around, I'm going down and around. How much is pi if I went a normal, or how much is pi over 2 if I go a normal amount? How many degrees is that if I go normal distance from 0 to pi over 2? How much is that? 90. So instead of going positive 90, we're going to go down and around and go negative 90. So I'm stopping right here, and that is this angle, 3 pi over 2 or 270. The negative just means I'm going down instead of up. You okay with that? Yeah. Awesome. Anybody else questions? I think the last one actually might be the easiest one. Cosine of 0. Cosine is what in terms of X and Y? X. And what's your X at 0? Awesome. 1. Okay, I have some practice problems like this on the sheet that I'm going to give you. Again, while it's not due, I highly recommend doing this because these types of problems will be on your quiz tomorrow. Can you use your unit circle? The answer is yes. For the quiz tomorrow, the answer is yes, you may use your unit circle. But you need to know how to use it. If you pull your unit circle out and you're like, I don't remember what sine is, or I don't know how to get tangent, I'm going to be like, sorry, I gave you all your tools. You got to learn how to use them. Okay, we're going to jump over to the next side of the paper, and we're actually going to do number 7 first, and then we're going to do number 6. So I want to do number 7 first because it's still looking at my unit circle. Number 6 doesn't have our unit circle. So we're going to do number 7 while we're already in our unit circle mind. We have done problems like this before, but before I said, okay, we're only worrying about quadrant 1, only look at quadrant 1, you're only caring about quadrant 1. Now I care about all of the quadrants. Hi, Bryce. That's okay. Maya's taking your test, so if you can sit over there, that'd be great. So we're caring about all quadrants. Now I want to remind you something I taught you last week, which again, I'm sure wasn't preoccupying a lot of brain space this weekend, which is okay, is your ASTC. Do you guys remember when I taught you that last week? So just a reminder, in case you forgot, those are the letters, those help me remember which trig functions or function is positive in that quadrant. So the A means that in quadrant 1, all of the trig functions are positive. Sine and cosine and tangent and all their reciprocal functions, all of them are positive in quadrant 1. In quadrant 2, it's S because only sine is positive. Only sine is positive in quadrant 2. T in quadrant 3 is for tangent. Only tangent is positive in quadrant 3. And then C is for cosine. Only cosine is positive in quadrant 4. So on all of these, I'm going to give you a trig function. And I'm going to tell you whether it's positive or negative. And that's going to help us kind of narrow down the search on where we're looking. So if I'm looking at this first one, this first box says cosine of theta equals -1/2. Okay, cosine here is negative. So I want to identify which 2 quadrants cosine is negative. Where is cosine positive? Tell me first, where is cosine positive? 4 and 1. So that means it's negative where it's not positive. So it's positive in 1, so it's not negative there. It's positive in 4, it's not negative there. I'm caring about 2 and 3. So in quadrants 2 and 3, I'm looking for what my cosines are going to be. I'm going to erase those though, because I want that little reference there for me. So I'm looking in quadrant 2 and 3, and I'm looking for my cosine to be -1/2. Cosine is what in terms of x's and y's? X, good. So I'm going to go look in quadrant 2 and 3 and figure out what x's have a -1/2. Anyone see them? What'd you say, Ethan? 120 and 240. And then this direction said, give me radians and degrees. So give me the radians with it too. So 120, and I believe that is 2 pi over 3 and 240, which I believe is 5 pi over 3. Am I right? 4 pi over 3. Thank you. Got a little excited. I jumped too far. Okay, so that's all it is. We're identifying which quadrants we're looking in. And then based on the trig function and ratio they give us, we're going to look at which angles those are. All right, should we do the next one? The next one is sine of theta equals √3/2. Okay, that's positive. So my first question is, what quadrants is sine positive? 1 and 2, very good. So we're looking in quadrants 1 and quadrants 2. Okay, so, and y is which variable? Oh, I messed that up, didn't I? Sine is which variable? By the end of the day, I have these leading questions in my head, and sometimes they get all mixed up, and I just tell you the answer. My question was, sine is which variable? And the answer was y, and I just ruined it. So we're looking for where my y is √3/2. And we're looking only in quadrant 1 and quadrant 2. What angles is that at? 60 and 120, good. And that's pi over 3. And 120 is 2 pi over 3. I want to actually skip and do letter D since we're kind of on like an easier track. Letter C has tangent, so that's going to be a little tricky. We'll kind of wait a second to do that one. You guys ready to jump down to letter D? Okay. Letter D says sine of theta equals 1. Okay, that's positive. Where is sine positive again? I think you just told me. 1 and 2. And sine we know is y because we just walked through that. So where in quadrants 1 and 2 is my sine 1? Where in quadrants 1 and 2 is my sine 1? What'd you say, Will? 90 degrees. The only place it's 1 is at 90 degrees. And I know I don't have my little unit circle up here, but I only am caring about these top 2 quadrants, and y is at 1 only at 90. Every other time it's 1/2, it's √3/2, it's 2/2, or even on the other axes, my y's there are 1. So the only one place on this unit circle I could be talking about is 90 degrees. Okay, questions yet? The last one we're going to do is a little tricky, but I'm going to argue it's not that tricky. It says tangent of theta equals 1. So I'm looking at where tangent is positive. Which quadrants is tangent positive? Quadrant what one? 1 and 3. 1 and 3, very good. And I want to know where tangent is 1. What is tangent in terms of the variables, in terms of x and y? Y over x. So I want whatever my y divided by my x is to equal 1. The only way that can happen is if the same number is on top and on bottom, right? If I did like 5 divided by 5, that's the only way I'm going to get 1. So I'm looking for an angle who has the same values for x and y. 45 and 225. So the only way to get 1 is if I do √2/2 divided by √2/2. I know that that seems messy, but when I go to multiply it out, when I go to get rid of that double fraction, √2/2 times 2/√2, when you multiply by the reciprocal, the 2's and the √2's cancel. So that's how I just get to 1. This is one of those patterns that I kind of keep in my head now that we've done it a couple of times. I'm like, oh, anytime I have tangent of 1, I'm thinking of a 45-degree angle, and I just want to do where it's true. So I'm in quadrant 1, so I do get to use 45, and I'm in quadrant 3, which means I have to use the 45-degree angle there. Ethan, question? Yes, you do. You may need to watch the video because I've got one more type of problem that you haven't seen yet. Yep, thank you. All right, anybody questions on these so far? The very last type of problem I'm going to argue is not new, but it's going to combine a lot of things that we've talked about. Any questions yet? Okay, we're going to jump up to number 6, the one that I made you skip earlier. And this one says use the given to find the desired values. So it says if cosine of theta is 2/3 and tangent of theta is less than 0, find sine and cotangent. I'm only going to worry about the if right now. I'm only going to worry about this part. Just like we've been doing before, if I don't give you a picture, you got to draw a picture. So you got to find a picture. But I don't want just any picture. This in the if tells you what picture to draw and where. It says cosine of theta equals 2/3. What's cosine in terms of A's, O's, H's? Adjacent over hypotenuse. Okay. So when I draw my triangle, my 2 is going to be my adjacent, my 3 is going to be my hypotenuse. That seems okay, right? We've kind of done that before. Now, this cosine is positive. What quadrants is cosine positive? 1 and 4. Very good. So right now, all I know is that my adjacent is 2, my hypotenuse is 3, and I could be in the first or I could be in the 4th quadrant. It also, though, tells me tangent of theta is less than 0. Is that positive or negative numbers? Negative. So that means my tangent is negative. And in what quadrants is my tan negative? 2 and 4. I have to draw this triangle where both of those things are true. Which quadrant am I going to draw this triangle in? 4. In order for cosine to be positive, it has to be in 1 or 4. And in order for tan to be negative, it must be in 2 or 4. And the only place that they overlap, that they connect at, is quadrant 4. So we're going to draw a little coordinate plane. We're going to put our triangle in quadrant 4, and we're going to label our adjacent and our hypotenuse as 2 and 3 respectively. And then don't forget, again, I know it's been a few days, don't forget your theta always goes by the origin. And I'm gonna go ahead and label my O and A and H. I feel like you already know that, so I'm not gonna wait for you. Is that okay? Let me actually move this up a little bit so I know that I need to find that side.
You be recording this way.
I am recording right now. Okay, so we figured out what quadrant we're in based on the all students take calculus, which I taught you last time. We labeled our triangle based on cosine is A over H, which I taught you as a sophomore, but we reviewed a few days ago. And then we labeled our triangle based on kind of all this knowledge that we've gained up so far. The next step I need to do is find the opposite side. How do I do that? Pythagorean theorem squared. A squared plus B squared equals C squared. Very good. So I'm going to do 2 squared plus X squared equals 3 squared. So 4 plus X squared equals 9 minus my 4 from both sides. X squared equals 5. So X equals root 5. Now, as I go label this in my picture, is it going to be positive root 5 or is it going to be negative root 5? Why is it negative? Very good. Based on like what we knew from like pre-algebra, like we know graphs in quadrant 4, I went down root 5, so I have to represent that by negative. That's also going to be helpful to keep my all students take calculus true, that if this opposite is negative, then cosine will be the only thing that's positive. Now, I know it only asks us for sine and cotangent, but sometimes I get bent out of shape or do the wrong thing on accident if I don't do all of them. So I'm going to do all 6 of them. I'm going to make myself a little chart like we've been doing this whole time. I'm going to say sine of theta, cosine of theta, tan of theta, and then do all my reciprocal functions next to it. Cosecant theta, secant theta, and cotangent theta. Just setting myself kind of up for this success. And then once I have all of these, then I'll just be able to identify the ones that they actually want from me. All right, you have your picture, so you won't be jumping in and out of Zoom like I am. So, okay, let's see. Got negative root 5 over 3, 2 over 3, negative root 5 over 2, and then all my reciprocals. You are welcome to rationalize and simplify if you want. You do not have to. Kind of a personal preference here. Again, my rule of thumb has been with unit circle stuff, definitely rationalize. Other than that, it's kind of a personal choice. And again, it said sine and cotangent. So I'm going to highlight these because this is really what it asked for. But again, sometimes I get myself all worked up and I forget like what cotangent is if I don't do them all in order. So I find if I do sine, cosine, tangent, and then reciprocal all of them, then I get them all correct. Okay, I've got one more problem like this and then the rest of class is yours. You guys ready to do this last one? Anybody questions yet? Again, you guys would argue this isn't really new stuff yet. It's just combining a lot of things, right? It's about kind of reading the directions and seeing these types of problems. Okay, so this one says if sine of theta equals 1/5 and cosine of theta is less than 0. Okay, sine is, we'll label that, what is that in terms of O, A's and H's? Opposite over hypotenuse. And sine is positive. So what quadrants is sine positive? First and second. Thank you, Ava. And then cosine is less than 0. Is that positive or negative? And where is cosine negative? Second and third. 2 and 3. If you have trouble figuring out where is it negative, I like to say where is it positive and then decide from there which is it not positive. So if I know cosine's positive in 1 and 4, then the other 2 and 3 is where it's negative. Which quadrant am I going to draw this shape in? Quadrant 2? Draw your shape in quadrant 2, draw your triangle, and then label your opposite 1 and your hypotenuse 5. Theta goes by the origin, opposite is 1, hypotenuse is 5. We do not know the adjacent. We're gonna have to find it. While I'm thinking about it, I am labeling my sides opposite, adjacent, hypotenuse, so I can figure that out really quickly. You guys are pretty good at Pythagorean theorem, so I'm gonna go ahead and do mine. I've got 1 squared plus x squared equals 5 squared. One plus x equals 25 minus 1, x squared equals 24. So x equals root 24. And while I'm okay with you not rationalizing, I would like us to simplify our radicals, just kind of get in the habit of that. So that becomes 4 and 6. Oh, and that 4 becomes 2 and 2. So I can make that 2 root 6. That's my adjacent. Is that going to be positive or negative 2 root 6? It's going to be negative again. Now, I know we've just done 2 examples with 2 negatives in a row. That does not mean every time you do it like this, you're going to have a negative. Just like really read your graph, really look at what's going on. Since I went to the left on my x-axis, that means it's a negative. So just think about like, what did I do? Does it make sense that I'm at negative 2 root 6 now versus positive 2 root 6? And again, it wants secant and tangent. If you can do those independently, awesome. I can't, so I'm going to make my little chart out and then I will highlight secant and tangent. So go ahead and do those if you have not already. Okay, so there's one of and they said secant and tangent. Okay. That is all I have. Anybody have any questions for the good of the group? I have this paper again, which I will not necessarily collect for points, but I think is a really good thing to do. This is what I suggest you working on next. If you choose not to do this, homework is another great option of something to do.
So
Homework is due next class.